This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 5, Lesson 2, Cooling Towers and Fluid Coolers. This is where the chiller finally rejects its heat. Condenser water trickles down through the fill, a little of it evaporates, and the rest comes back cold. Two temperatures grade the tower: range, how much the water cooled, and approach, how close it got to the wet bulb limit. We'll define both on a schematic. Contrast the 15,000 BTU tower ton against the 12,000 refrigeration ton. Then, size a tower and its makeup water. Concept 1. How a tower is graded. Warm condenser water falls through the fill, while air is pulled up. Evaporating a small fraction of that water is what carries the heat away. Two prose definitions grade the tower, and there is no formula to render. Range is the entering hot water minus the leaving cold water, how far the water dropped. Approach is the leaving cold water minus the ambient wet bulb, how close the tower got to the limit, and that limit is the wet bulb, never the dry bulb. Concept 2. The ton that bites. A refrigeration ton is 12,000 BTU per hour of cooling delivered to the space. But the tower must reject more than that. It dumps the evaporator load plus the compressor work the chiller added. The handbook bakes that in as a cooling tower ton of 15,000 BTU per hour, about 25% more, the heat of compression at a chiller efficiency near 0.88 kilowatts per ton. Size the tower on 15,000. Size the chiller on 12,000. Setup. Part 1. Heat rejection and tower tons. The tower rejects everything the chiller pushes into the condenser water, so start on the water side. Heat rejected is mass flow times specific heat times the range. Get the mass flow from the volumetric flow through the usual pound per gallon and per minute conversions. Then tower tons is that heat rejection divided by 15,000. Setup. Part 2. Makeup water. Every drop that leaves has to be replaced, along 3 paths. Evaporation is the dominant one. The handbook sizes makeup as if all the rejected heat leaves as latent. Drift is the droplets carried out the stack, small. Blowdown is a deliberate bleed that keeps dissolved solids from building up. Evaporation is the heat rejection over the latent heat, or equivalently, the GPM times range form. Blowdown is the evaporation divided by cycles of concentration minus 1. An open cooling pond gets its own printed evaporation rate. Solve. Part 1. The tower tons. 1,000 gallons per minute of condenser water cooled 15 degrees. Mass flow times specific heat times range gives 7.5 million BTU per hour of heat rejection. Divide by the tower ton and you get 500 tons. Divide that same load by 12,000 and you would read 625, the classic ton trap, a 25% oversize. Solve. Part 2. Makeup and blowdown. Use the printed GPM form directly. Flow times range over the latent heat gets 15 gallons per minute of evaporation, and the mass form checks to the same number. Blowdown is that evaporation over cycles of concentration minus 1. 5 gallons per minute at 4 cycles. Add a little drift, and total makeup is about 20 gallons per minute, roughly 2% of the circulated flow. Traps. 5 ways this bites. 1. The tower ton is not the refrigeration ton. Reject heat on 15,000. 12,000 is the space cooling. 2. Approach is measured to the wet bulb, never the dry bulb. 3. Range is hot in minus cold out. Approach is cold out minus wet bulb. Different subtractions. 4. Makeup is evaporation plus drift plus blowdown, and blowdown is evaporation over cycles minus 1. 5. The 500 factor is a derived conversion, not a printed constant. The handbook prints mass flow times specific heat times delta T. Quick recall. Range is entering hot minus leaving cold water. Approach is leaving cold water minus the wet bulb. Tower tons is the waterside heat rejection over 15,000, not 12,000. Evaporation is the GPM form over the latent heat, and blowdown is that over cycles of concentration minus 1. Golden rule. Grade with range and approach. Reject on the 15,000 ton, and make up evaporation, drift, and blowdown. Next up, Lesson 3, Boilers and Furnaces, which the handbook really treats as combustion. will cover higher versus lower heating value, stoichiometric and excess air, and combustion efficiency, with the heating value denominator trap front and center. Everything's at PEPrepEngine.com. Cheat sheet, worked solution, and a quiz attached here. If the course helps,
The full study guide with every equation and common exam trap is free at PEPrepEngine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.